Hello, my name is Jeff Kindhart, and today we'll be talking about high tunnel construction and operation. High tunnels are the most rapidly adopted technology currently being used by fruit and vegetable growers throughout the Midwest. They are being adopted for a variety of economic and cultural reasons we'll discuss during this presentation. The definition of a high tunnel is a bit variable. Hightunnels.org defines it as an unheated plastic cover structure that provides an intermediate level of protection when compared between a greenhouse and a field operation. Other definitions tend to be much more stringent and specify that there be no electrical service or automated ventilation in addition to not having a heating system. Definitions vary from person to person, and actually they even vary from NRCS program by state to state, and so you need to look at your individual state's definition for what is or is not allowed for those of you that are wanting to participate in the EQIP program. I simply like to view high tunnels as being any structure that doesn't have auxiliary heat. It may or may not have electric, it may or may not have automatic ventilation. But it is in contrast to what's seen in the upper left, which is a low tunnel. High tunnels afford the room for both people and equipment to work inside of the structure. Some of the crops that are commonly grown in Illinois include tomato, pepper, cucumber, raspberry, and strawberry. Blackberry is a crop that would be useful in northern Illinois. In southern Illinois, although blackberries can be raised in a high tunnel, we don't see the same economic boost in production from blackberries that we would see from a crop like raspberries. However, in northern Illinois, where blackberries are only marginally hardy, they might be a great choice for a high tunnel operation. Lettuce and other greens are a very valuable crop for production during the wintertime especially. With the use of lettuce and other greens, it's likely you can have a continuous harvest inside of the high tunnel environment for all but 3 or 4 weeks in late December and early January. When we think about high tunnels, there's a couple of different ways these can be done. Homemade is one of the options, and I'll be honest, it's not my favorite. Typically, growers who go out and make their own do that for 1 year. It is moderately successful. They have a significant investment in the pieces and parts that they bought for their homemade constructed high tunnel, and most of those wind up getting set out in a fence row, and the following year purchasing a prefabbed greenhouse. If you're going to make your own high tunnel, if you've got a small tunnel that you're going to make, you can make jigs and bend the pipe like you see in the lower right. For larger structures with heavier pipe, the use of either a hydraulic or pneumatic pipe bender, like seen in the upper left, may be required. I think most growers are likely better off purchasing a prefabricated structure, and there are a variety of places where these can come from. One of the better sites that I saw, Mississippi State, has a website that contains information on over 30 manufacturers in terms of their contact information. Additionally, if you're going to participate in the NRCS EQIP program, your state will also maintain a list of licensed vendors that they accept for high tunnels in their program within the state that you reside. When we buy these structures, they come in basically 3 different shapes. This is a Gothic, and if you'll look, it's got a bend in the middle of the roof, and this design is to allow snow to shed slightly better compared to a Quonset, which is a smooth bend all the way across the top. Quonset are likely still the most common types of structures that we would see in the state of Illinois. The third choice, which is a gable structure, and if you look, a gable structure has a very steep roof pitch to allow even better snow shed than what we see from the other 2 types of structures that we've looked at. These structures may be, as in the previous three pictures, single freestanding units, or they can also be put together as gutter connected units. In this case, you're seeing a gutter connected Gothic style greenhouse. This is a gutter connected Quonset type high tunnel, and in this case it's also sometimes referred to as barrel style, because as you look at the end it looks like a group of barrels have all been rolled together. And this is an example of a gutter connected gable greenhouse, although we could also have a gable connected high tunnel. Again, the difference basically between a high tunnel and a greenhouse is just whether or not we have included auxiliary heat. Site selection is very important for a high tunnel. This is an example of a poor site for a high tunnel. Although I think that aquaculture is a good thing and horticulture is a good thing, probably we don't want to do them in the same structure like in this example. In other words, if we're raising tomatoes and catfish together, we may have chose a poor site. The site should be elevated to afford both good air drainage and good water drainage. Do remember that these structures are not built like a house. They are subject to the forces of nature, and we commonly can see wind or snow damage. Here's an example of wind damage, and this was taken a month ago in southern Illinois. In 2 counties I'm aware of 5 different high tunnels that collapsed due to ice and snow load, just like this picture that you see here. Once you've decided what type of structure you're wanting to buy, you've decided you've got an interest in high tunnels, the next thing that you should do is check with your local government and ascertain what zoning ordinances or building laws are going to be applicable to you. The last thing you want to do is order a high tunnel, have it delivered, and then find out that you're not going to be able to erect it on the site that you had in mind. So do your homework prior to placing. Once you have ordered, this structure is going to come by tractor trailer, and it's awfully helpful if you have a substantial tractor, probably something 70 horsepower or bigger, with a front end loader equipped with forks to help unload the unit. In fact, in some cases it's actually handy if you have 2 tractors with front end loaders and forks. If you don't have this option, these can be offloaded by hand, breaking down the boxes and throwing everything out the back of the truck. There's really 2 problems with that. One, it's a great opportunity to lose smaller pieces and parts when you have to unbox it out the back of the truck. And secondly, it tends to make for a very mad tractor trailer driver. Once your tunnel's on the ground and you open the box, you're going to discover there's all kinds of pieces and parts. And let's just go through real quickly and look at what a few pieces and parts consist of. When we look at a typical high tunnel structure, we've got some just basic components that exist. Most of them are going to tend to have ground posts that are going to make the vertical walls that separate the ground from the bows. The bows are going to be the upright pieces that form the roof, if you will, of the structure. And those bows are kept from sliding back and forth by devices that run the length of the structure called purlins. And the number of purlins will vary from greenhouse manufacturer or high tunnel manufacturer to manufacturer. In addition, you can also see there's a hip board that is placed where the roof and the sidewall meet, and normally this is going to receive some sort of fabricated extrusion, and that's where your wiggle wire will be inserted. This is how the plastic is held in place on the structure. This is an example of wiggle wire being worked into that extrusion, and that is what holds the plastic in place. In addition to the hip board, which you see across the top of this picture, We also have a baseboard, which you see at the very bottom at the sidewall. If you look at the sidewall all the way down at ground level, you'll see that there is a baseboard that is put there, and that baseboard is put in place to keep wind and water and rodents from infiltrating the structure. If you're going to be an organic producer, do be advised that the hip board and baseboard cannot be made out of treated lumber. High tunnels have sides that can be opened or closed to provide ventilation. This is an example of a drop-down curtain on a high tunnel. In contrast to the drop-down curtain, this is a curtain that rolls up to afford ventilation. There are advantages and disadvantages to either type. The ground post and bows are commonly spaced at 4 to 6 foot, although other spacings are occasionally available. 6 and 4 foot do tend to be the most. The ground posts are held in place most commonly by one of three methods. The left picture is a short piece of pipe, normally around 3 feet, that is pounded into the ground, typically with a sledgehammer. While cheap and perhaps the easiest, it's not always the most effective at keeping your structure where you'd left it. The middle picture shows a foot that the ground post will sit inside of and become secured to. This is commonly employed where the grower is putting a structure up where there's already existing concrete. Old confinement hoghouse operations are typical examples of where this would be used in Illinois. The right-hand picture shows ground posts that have been set in concrete. A fairly common configuration is an 8-foot ground post that's set 2 foot below grade into 42 inches of concrete. This results in a 6-foot sidewall being. There are also movable high tunnels. Although less common than stationary tunnels, they can be used in a fashion that a single tunnel may provide protection to 3 separate sites and 3 separate crops, or even more than that. In some cases, these tunnels roll along fixed pipe, and in other cases, tires are placed along the base of the structure. The structure is rolled to its new location, and then the tires are removed. Once in place, whether by rail or with tires that are installed and then uninstalled, the structure is pinned into place using large stakes or rods made out of steel. One additional consideration for your high tunnel is the bow configuration. Cheaper tunnels tend to have open bows, and more expensive tunnels have some means of trussing. Here are some common truss configurations listed in order of strength. Trussing is important in areas that are going to have high snow or wind load, or if the grower is planning on placing a significant amount of dead load on the structure, such as by trellising a crop up into the roof of the high tunnel. This is an example of a tunnel that has a very low load capacity. Plastic must be removed every winter because it is not capable of supporting snow load. However, this structure provides cheap protection on a per square foot basis for growers to install and uninstall the cover frequently. Here's an example of a tunnel that is commonly seen in Illinois, and it does have one significant problem, and most growers that have this tunnel go back through and have to fix it. There is no center purlin on this tunnel, and we wind up with problems occurring because of that. And so, as you can see in this case, a 1x3 board has been utilized to form a center purlin down through the middle of the structure. In general, there should be a ridge purling, and typically the more purlins, the greater the durability and stability of the structure. In this particular case, this structure has 5 purlins. This is an example of that 5 purlin structure that we had just looked at. It has an open bow configuration, and it had just been finished with the construction process. This is a high tunnel that has a W truss if you look up in the ceiling, and so this structure has quite a bit higher load rating than the previous structure with the open bow configuration we had just. End walls are normally not part of the high tunnel package itself. They may often be purchased as a separate kit, or many growers choose to construct their own. The end wall construction is very important, and though not always well done, it is a critical part of keeping your greenhouse intact and avoiding damage. In this case, the end walls are going to be quite durable. It looks like it's well constructed, and they utilized treated lumber for their materials for constructing their end. End walls can also be made out of steel or aluminum materials like you see being utilized here. Here's an example of one of our high tunnels at the Dixon Springs Ag Center, and in all honesty, we only have 3 uprights in our end wall, and it really is not sufficient enough, and we're going to rebuild that between now and next spring. The material used to cover a high tunnel is often referred to as glazing, and we have a variety of choices when we consider what our glazing is going to be. Poly or polyethylene is most commonly used because of its low expense. It may be installed as a single layer, or in some cases growers may install 2 layers and then use a small inflation fan to blow a dead airspace in between the 2 layers of plastic. This is commonly referred to as double inflated poly. Double inflated poly has a very good R value, and it also tends to reduce the amount of condensation that we see when compared to cloth or single layer poly. Greenhouse cloth or fabric is also a fairly common material for high tunnels. It is supposed to be more durable than poly, and it has a higher R value than single poly, but not as high of an R value. The last glazing material we'll talk about is polycarbonate, and it does come in a variety of configurations, but what we see most commonly used is going to be this twin wall polycarbonate like you see here that has a dead airspace in it. The amount of dead airspace or the thickness of the overall material varies from 8 millimeter all the way up to 20 millimeter, and of course the thicker the dead airspace, the more expensive the material is. Polycarbonate is very durable and has a high R value, but because of its expense, it is normally used only sparingly for high tunnels, and in most cases it is relegated only for end wall construction, as you see in the bottom right hand picture. Well, now that we've talked a little bit about high tunnel choices and configurations, we're going to spend some time talking about the actual construction of a high tunnel. Before you begin, first determine the length of the diagonal based on the size of your actual structure. This can either be cranked out with the Pythagorean theorem, or my personal choice, you can find a chart like this one on the internet and look up the length and width of your building, and it will tell you the length of the diagonal. This is important for maintaining the building be true and square, and we also like to use it to form this. We found it helpful to get 6 pieces of string, 2 each cut to length and width and diagonal. The strings are then attached to 4 stakes. When you draw the 4 stakes out all the way so that the string is tight, you now have the exact 4 corners of your building. This is a very helpful step for those of us that are not in the habit of siding buildings, and it allows us to make subtle changes in the exact location of our building prior to the construction of the batter board. Once you have determined the exact location of your structure, it's now time to construct a set of batter boards at each of the 4 corners of the structure. Two nails are placed in each horizontal board on the batter board, one at the exact dimension of the structure and the other nail placed 1/2 the diameter of the pipe away from the original nail. This is a critical measurement and must be done without slack in the tape measure. Once the nails are in place, a string is stretched taut between the nails, and we want that string to be pulled absolutely as tight as possible. This string is going to tell us the exact outline of our building. Once we've located our first corner post, we then use a tape measure to measure either 6 or 4 or 5 feet, whatever our ground post spacing is, typically 6 foot, away from the center of the first corner post. And that 6-foot measurement is going to tell us the length of exactly where the post is going to go. We then drop down a plumb bob from the string suspended from the batter boards, which gives us the exact width. At this particular point, we like to place a roofing nail at the exact spot where that plumb bob and the 6-foot mark on the tape measure intersect. Once the roofing nail is in place, we use this very fancy handcrafted recycled 5-gallon plastic bucket as a marking stencil. Notice we punched a hole in the middle of the bucket, and we then place that middle of the bucket right over the top of our roofing nail that we had placed in the ground. Once the bucket is in place, we paint the center and the outside of the bucket using ground marking paint, as you see here. The result is a bullseye, which allows for easy alignment of the post hole digger when it's time to come in and bore the ground post holes. If you are using ground posts that will be pounded in, at this point you're actually done and you drive your ground post exactly where that nail is. Those of you that post hole digger, then your next step is to come in, and typically we're going to have a depth that has been specified. 42 inches is pretty common, and we're going to bore a hole to the depth. It is important to note we should have called someone like Julie and located all existing underground utilities prior to this step. This is the first step where we can get in trouble if we have not contacted the correct authorities and had the utilities located on our property. Once the holes have all been dug, then the string is shifted on the batter board from the exact position to the second nail position, which was 1/2 the diameter of the pipe away from the first nail. The point now where the strings cross is the exact location of the outside walls of the corner post. You can see the corner post being aligned here. Corner posts are usually set with hand mixed concrete. They are plumbed in both directions and set at the correct depth so that we obtain the correct sidewall height. We use hand mixed concrete because this gives us all the time that we need to make sure that we have these corner posts set truly plumb and at exactly the correct height. Once the corner posts have been given time to set up, the strings are then placed as you see here. We've added additional strings that go around the corner post all the way from one end of the structure to the other, and we've run another string up the top of the corner post. These strings are what we will use to mark all of the rest of the pipes or poles that form the side. A concrete truck is then brought in, and after several hours of wheeling concrete and adjusting post height and all that good stuff, The following morning you come back and all of your posts are still sitting there right where you left them from the night before, and hopefully everything is nice and square and plumb and straight. Once the posts have cured, the bows are assembled and hoisted into place. This can be done with a front end loader or a high lift. The first bow is normally held in place with a rope because there's nothing there to hold that first bow, and that rope remains until we have maybe 3 or 4 bows in place and have enough center purlin down through this structure that the bows themselves will not be capable of shifting. Much of the work will occur high in the air, requiring scaffolding or a cherry picker. All the bolts should be placed facing the same direction to reduce chances of damaging the polyethylene cover or the greenhouse fabric when it is going to be installed later. So once you've decided which side of the tunnel the bolt heads are going to be on and which side the threads are going to be on, try to keep that same pattern for every single bolt at every single location throughout the construction process of your high tunnel. By far, the last bow is always the prettiest. It looks amazing when you get that last one put into place and the center purlin on it. After all the bows have been in place, the remainder of the purlins are typically installed. Once all the purlins have been installed, we have to go back through the structure and locate all sharp corners. All sharp corners must be covered with duct tape to prevent damage to the cover that will be later installed. This is very important. Failure to get one sharp corner will result in ripping your plastic and having to buy a new cover. If you're using a kit that has curtain type end walls, which is pretty common, for example like in this FarmTech house that you see being constructed, it is at this point that those end wall curtains will be lashed into place onto the bow, and then the extrusion will be installed over the top of that lashing. That extrusion is going to hold our cover in place. It is noteworthy that every day that you're trying to install your high tunnel or put on your greenhouse cover, the wind will likely blow at a fairly significant rate. Fear not, it won't blow when it's really hot in the sun. It's at this point that it's time to start installing the cover, and you can see Julie is working here, working wiggle wire in and installing the cover. The large cover is normally pulled in place by 4 or 5 individuals. Once it's pulled over the top of the structure, it is then stretched taut between an individual on either end of the greenhouse, and what tends to work best is starting at the middle and then working your way down. In this case, you can see Julie's about halfway down the first side in the installation process of this cover. This is the person on the opposite end working opposite of the first individual that we saw, attaching the wiggle wire in the exact same fashion, both of you working in the same direction. By starting in the middle and working your way down, you avoid winding up with a lot of extra slop or slack in your covering. At some point during this construction process, and it could have been prior to installing the cover, or it may wind up being after installing the cover, it is a good idea for everyone and a requirement for those participating in the EQIP program that we install a perimeter drain like the French drain you see installed here. There's a substantial amount of water shed from these structures, and rather than having some of that water run back in underneath of the baseboard and into the high tunnel environment, we would rather that water be carried away where it doesn't cause damage to our crops or make the soil inside the tunnel too waterlogged. And perimeter drains are an excellent way of removing this excess moisture. Here's the interior of a structure immediately after construction has been completed. Once the ground has dried down, it can now be worked, and here's a picture of tillage operations occurring inside of the high tunnel after the ground has dried. If you'd note, it took about a week for the ground to actually dry out to the point where we could work it, and that's fairly typical. A lot of these go up in the springtime, and it tends to be pretty wet in the spring, so before we get the cover in place, oftentimes the ground is fairly moist. But once we get it covered up, usually in about a week or so, the ground will dry out and we're able to resume our groundwork activity. Some growers use raised beds that are constructed by hand. Some use tractor-mounted equipment to make their raised beds, and still others may opt for the construction of permanent raised beds, which is what you see being done in this particular slide. Permanent beds can be worked with a small gas or electric powered tiller like you see being done here. While we're working in the ground inside of the bed, it is at that point that we normally take care of any fertilizer that may need to be applied. Fertility is a really important aspect to high tunnel production as well as all horticultural production, and it will be the subject of an entire course later in this Beginning Farmer Rancher series. Things that are kind of different about fertility inside of a high tunnel are special considerations for fertility inside of the high tunnel. Cropping cycles are often shorter, so we have to be careful with organic or slow release fertilizers, making sure that they're going to be plant available within the cropping cycle time that we're going to be dealing with. The very high density that typically is going to be present in a high tunnel should impact fertilizer recommendations, but when we ask soil fertility experts exactly how, their answer is often unclear. Small raised beds require careful calculation and measurement. There's not a very big area in terms of an acreage basis in a 2-foot by 90-foot long bed, and so when we are doing our mathematical transformations, we have to be very careful that we don't misplace a decimal point. If we mess something up, we can have problems with either not putting on enough fertilizer, or more commonly the case, putting on 10 times the amount of fertilizer that we should have, and then salt buildup can occur. Normally in the high tunnel environment, we're looking at a split application, at least for nitrogen, where we're putting on some of the fertilizer that is required pre-plant in the bed, and some of the fertilizer will be fertigated or applied through the irrigation. Fertilizer is applied through the irrigation water most commonly by using a proportional injector like the one seen here, and we will spend more time talking about injectors during the irrigation section of this Beginning Farmer Rancher. But simply put, fertilizer, water-soluble fertilizer, will be mixed with water, and as we are irrigating, we will be not only applying water, but applying fertilizer as well as the water for irrigation. Once we have our fertilizer in our beds and we've got them worked just the way we like it, we now come back and screed the bed. And we want these beds to be as full as possible so that when we install our black plastic mulch, the black plastic mulch is actually touching the dirt in the bed and not just laying over the top of the dirt with a dead air space in between them. Black plastic mulch only works well if we've got it in actual contact with the soil. So you can see here, we've filled the bed, we've worked the ground, we've applied our fertilizer, and now she's coming back through with a screed board and shaking that bed back down to level. Once the beds are screeded, then 2 drip tapes are put into place and black plastic mulch is installed. In our case, we simply use a tacking stapler to hold the mulch to the wooden boards that are part of the raised bed that we have constructed. plants are normally set by hand. Bulb planters, like the one seen in Julie's left hand, are commonly used to make the planting hole for this operation. They are easily obtainable at any hardware store or garden center, and they work very well. There are some special spacing issues when we talk about production inside of a high tunnel as compared to production in an open field. Tunnels are expensive real estate, and so typically we have tight spacings on our plants that we're setting so that we get higher yields. There is some trade-off in that tighter spacing, while it does tend to increase yield, can also increase insect and disease problems. Tighter spacing may also impact cultivar performance. Some varieties that do well at wider spacing may not do as well under the tighter spacings that are likely going to be in. Here's some tomatoes in a high tunnel just after planting, and the plants are off to a nice start. Early plantings of frost-sensitive crops, such as the tomatoes you see here, require the use of row covers to form a low tunnel within the high tunnel. A lightweight row cover will protect to a much greater extent inside the high tunnel environment than you would be accustomed to in an outside environment. Because the wind doesn't blow in the tunnel, we get a much higher degree of protection from lightweight covers. In this particular case, what you're seeing is tomato crop after 2 nights of 16-degree weather outside, and only the 2 northmost plants on each row were damaged. Without the lightweight row cover, the entire crop would have been lost. While tomatoes commonly are trained regardless of whether they are raised in the field or in the high tunnel, many crops like cucumbers and peppers are commonly trained inside a high tunnel, even though they would not be trained in an outside environment. Why is there this difference? The value of the space dictates careful consideration of training systems, and because we tend to plant at high density, we need to get as much of a vertical element out of the crop production as we possibly can, and so therefore training and trellising become much more important. Another thing is that cultivar selection may predicate the type of training system that is going to be used. For example, determinate tomatoes may be grown using a trellis weave, as is commonly seen outside, but indeterminate tomatoes are normally trained to a single leader and affixed to an individual string dropped down from above. These are various trellised crops inside of the high tunnel. And note that in most of these cases, like the hog panel that you see that the cukes are growing on, the structure itself is not carrying the weight of the crop, but the trellis is what's carrying the weight. In other words, these aren't being trellised to the frame of the high tunnel, but rather they're being trellised to the hog panel, which is being supported or carried by the ground itself. Since so many of the tunnels are not capable of supporting a significant amount of additional dead load in the form of crop, it becomes important that if we're going to have a trellis, we want to have one that is basically capable of supporting itself and the crop rather than relying on the tunnel. Here's another example of trellis tomatoes where we have got a trellis that is carrying the weight of itself and the tomatoes back to the ground rather than transferring that load to the infrastructure of the high tunnel itself. And this is a very, it's a very beautiful crop of trellised indeterminate tomatoes. Here are some other examples of trellising. In the case of raspberries or blackberries, brambles require a different type of trellis. Just a couple of wires are normally involved in their trellis, and the principal use of the trellis in this case is to hold the canes in place so that we have an alleyway that we can get up and down to work the crop. This is an example of a greenhouse that has a mixture of determinate stake tomatoes on the left and indeterminate tomatoes that are being trellised to a single string in the background. This is just another picture of that trellis. It was constructed out of treated 2x4 material, and the strings are being carried by high tensile electric fence wire that's run the length of the structure over the top of the wooden uprights that you see. Many crops raised in the high tunnel require either wind or insect pollination. Providing a mechanism for pollination, such as either bumblebees or electric vibrating pollinators or even leaf blowers, may increase yields. This is especially true for early production, when pollination will likely be occurring when the tunnel is not going to be open for ventilation. So the opportunity for insects to come into the tunnel is pretty non-existent, since the structure is not being opened, and the likelihood of there being any wind for wind pollination is also greatly reduced. So consideration for pollination is very important, but particularly important for the early production that we're wanting to achieve in these structures. Some crops, like squash, if you don't provide a mechanism for pollination, you'll simply have almost nothing at all to harvest. There will be no fruit that will be set and no marketable commodity produced. While the high tunnel environment tends to greatly reduce the number and severity of pest problems, it typically does not eliminate them. Pesticide applications are likely for both organic and conventional growers, even in a high tunnel environment. This is a steam generator that is being used by research, or being used in research projects by the University of Illinois. Steam can reduce weed and soil-borne pathogens very effectively. We're just trying to determine the economics of the application and the equipment cost to determine whether or not it's viable for the typical operation. As it does not ever rain inside of the high tunnel, irrigation is likely not only going to be used to supply needed supplemental water, but as we discussed earlier, it will also be involved in delivering part of the fertilizer that the crop's going to use. High density plantings and warm temperatures can result in a relatively high demand, particularly as the crop is maturing. Again, we would recommend that most growers use twin tapes on their rows in order to supply water more efficiently and more uniformly across the bed face. The irrigation needs to be managed, and it needs to be managed well. Otherwise, we may still experience block problems. There are some tools that are available to growers for use in managing their irrigation, and we're not saying that we don't want you to reach your hands underneath the plastic and see if the soil feels wet or not. Absolutely, that's one of the management tools that will be utilized. But we would also encourage you to utilize things such as tensiometers, which give us a little more concrete and less subjective measurement of soil moisture, and most growers feel that it helps them do a better job of managing their irrigation. The tensiometer, simply as the soil dries out, the needle or the gauge indicates that this has occurred. We turn on the water. As we turn on the water, the needle on the dial goes back to indicate that we have relieved the moisture deficit that has occurred. So it's useful for telling us when to turn on and off the water. Ventilation and circulation are also important in a high tunnel. Temperatures within the high tunnel environment are most commonly controlled by opening the side walls to allow heat to escape. The temperature at which ventilation should begin varies from crop to crop and also varies with weather conditions. Ventilating a tunnel at too low of a temperature can cost the grower plant growth and also delay early harvest. Failing to ventilate in a quick enough fashion can result of loss in yield by resulting in flower abortion or even plant mortality. Many growers will also install fans in the high tunnel for circulation like those that you see in the ceiling of this particular picture. Air circulation helps to control humidity and also keeps the temperature more uniform throughout the high tunnel environment. We are seeing an increasing use of shade cloth. Commonly it would be 40 or 50% white shade cloth, and this is being installed by growers in mid-July and will remain in place throughout August, and it helps reduce the temperature inside the high tunnel. The last area we'll talk about today is hydroponic production. Hydroponic production involves raising crops without soil, and it's useful for allowing production on sites with contaminated soil or very poor quality soil, and even where we have no soil at all. We talked earlier that some growers will erect high tunnels on the top of old confinement houses where we've got a concrete slab, and hydroponic production works well for them. Additionally, soil pathogens tend to be much less of a factor in hydroponic production. Hydroponic production is typified by having large yields of quality produce, and production tends to occur quite early. This is an example of strawberries being grown in a vertical stacking system in Pope County, Illinois, using hydroponic culture. And this is an example of tomatoes being raised in a Dutch bucket system in Union County, Illinois. And again, very high yields and very high quality produce are the result of this growing. So until next time, hoping that you find your pot of gold at the end of the rainbow in your high tunnel, have a great day.